So this is page 524, problem 60. And we have such an equation, 1 plus cosecant square of x times cosine square of x equal to cosecant square of x. So when we try to prove an equation is an identity, generally we begin with the more complicated side. So right now this limit side is more complicated, so we begin with this side. So let me use L for this limit side. And now you compare the limit side with the right side, you see the right side is cosecant square of x. This is our goal, our aim, right? We should keep this goal in our mind and try to convert this limit side to this right side. So to get this cosecant square of x, we try to make up a fact of this cosecant square of x on this limit side. So we try to factor out a factor of the cosecant square of x. Then inside you have the, if you factor out the cosecant square of x, then for this time you should have the 1 over the cosecant square of x. And then for the second time you have the cosine square of x. For the first time, actually, if you multiply this term by the cosecant square, then you just get 1. Then you go back to this original term, right? And then if you multiply this term by the cosecant square, then you get the second term in this limit side. So now this one, we may use the reciprocal identity. We know this 1 over cosecant square of x is equal to sine square x, right? So using the one of the reciprocal identities, you get the sine square x and then plus cosine square x. Now you can use the fundamental identity. You get 1 for this part. So you have the cosecant square x. And then we know this one is just equal to the right hand side, right? So L is equal to R. So that means this equation is really an identity. And then we finish the proof of this problem. Now let's go to the page 523 and let's look at the strategy for verifying identities. So step 1, work on one side of equation, usually the more complicated side. So in the last example, we just begin with the more complicated side, and keeping in mind the expression on the other side as your goal. Okay, you try to convert this more complicated side to the other side. Okay. Then step 2, some expressions can be simplified quickly if they are rewritten in terms of the sines and the cosines only. So we like to deal with the sines and cosine, okay, compared to the other 4 trigonometric functions. So generally, we try to rewrite the other 4 functions in terms of the sines and cosines. And step 3, to convert one rational expression into another, multiply the numerator and the denominator of the first by either the numerator or the denominator of the desired expression. And we will see one example for this step 3 later. And step 4, if the numerator of a rational expression is a sum or difference, convert the rational expression into a sum or the difference of two rational expressions. And we will see some example about this step. And step 5, if a sum or difference of two rational expressions occurs on one side of the equation, then find a common denominator and combine them into one rational expression. And we also will see one example about this step 5. And before we apply those strategies to verify the identities, let's look at one more example about factoring. And let's look at the problem 40 on the page 424. And we try to factor this trigonometric expression. So we have the 2 times sine square theta plus sine theta minus 2 times sine theta times cosine theta and minus cosine theta. And we know when we learn the factoring in Math140, we have the strategy for factoring. If the polynomial has 4 or more terms, then we need to do the grouping, right? So right now, this guy has the 4 terms, so we first do the group. Okay, first do the grouping. Actually, we may group the first 2 terms as one group, and the last 2 terms as another group. So now in this first group, we have the common factor sine theta. So let's factor this out. And in the second group, we have the common factor negative cosine theta. So we factor out this negative cosine theta. Then inside the parenthesis, we have the 2 times sine theta and plus 1. Now, in these 2 groups, we have the common factor 2 sine theta plus 1. So now we factor out this, and we have the 2 times the sine theta plus 1 and times sine theta minus cosine theta. Okay, and then done. Now let's go to the page 525 and let's look at the problem 68. And we need to prove this equation is an identity. Okay.